So basic principles of serology. So this lecture is going to be super short because there's some supplemental lectures that you'll have to listen to and watch based on like how to perform different pipetting techniques. Pipetting is something that should be shown through videos and explanations, like using hands-on like videos. So going through a PowerPoint doesn't really get across the message of how to use a pipette. So I did find some really good supplemental videos that show how to use a pipette, and you will watch those as part of your lecture requirement for this section. The other portion is basic lab math, and since everyone is kind of at a different place in basic lab math, what I did was I posted a lecture that I recorded previously that kind of goes through all of the major topics of basic lab math. So from chemicals and chemical composition to the mole concept, all the way up through performing dilutions, making solutions, serial dilutions, and that type of stuff. Some of this may be a review from previous classes. Other stuff may be new to you. So that supplemental lecture video is also posted to go through kind of the lab math stuff. And then there's a corresponding lab that's going to walk you through performing a serial dilution and actually doing some bacterial counting from that serial dilution. So just wanted to give you a heads up that this video is just going to give a few definitions because you have those supplemental videos that you have to watch. So serology is the study of fluid components in the blood, especially antibodies. Serum is the liquid portion of blood minus the coagulation factors. So what we do is we draw blood and then we let the blood sit and clot for about 20 minutes. And once it's fully clotted, then we can centrifuge it to separate away the serum from the rest of the clotted mess. So you have clotting proteins, red blood cells, white blood cells, all that kind of stuff is going to be trapped in the bottom, and then the top would be serum. For a lot of our serological tests, we then pour off the serum. So we will take the serum and remove it from all of the cellular components in the bottom. So then we can just do our testing on the serum itself without worrying about contamination with the underlying materials. There's also new blood tubes that have gels in them so that the gel forms a protective barrier between all of the cells and clotting factors and that type of stuff on the bottom versus the serum, which would be on the top. So there's like serum separating tubes where the gel would sit in the middle. Sometimes we refer to those as red gels in the lab, but different ways that we can separate out serum. Serum is the most frequently encountered specimen in immunologic testing. Unless we're doing like a whole blood count, then we would obviously need plasma because we need those white blood cells in that. It's separated from other components of a blood specimen via centrifuge. Ideally, we use fresh serum that has not been heated. For certain tests, complement may need to be inactivated, so complement may interfere with the test results. We would heat the sample at 56°C for 30 minutes. Storage, if testing is delayed, we want to store between 2 and 8°C, which is refrigerator temperature, for up to 72 hours. Frozen at -20 or below if longer storage is needed. There are different types of pipettes. Volumetric deliver only one volume. So every time you use it, it's going to deliver the same volume. Graduated are marked to allow for varying amounts. There's serological pipettes and blowout pipettes. And then micropipettes deliver small volumes. And those can be they have little dials on them and they can be adjusted to deliver specific amounts. So this just shows a sample of how to use a pipette. Again, with these types of pictures, it's easier to see it actually performed than to see a schematic drawing like this. So this picture is here for your reference, but I strongly encourage you to watch those supplementary videos that are provided. Reading the meniscus. So this is actually a really good picture because when you look at the meniscus, the upper edges are usually higher than the bottom center of the meniscus. So you definitely want to put your eye level at the center of the meniscus and read at the bottom of the the meniscus here because it does curve down. So the center of the meniscus would be the bottom of the meniscus, and that's what you're going to record as the volume. Honestly, even when I do cooking, like baking with my kids, if I pour some water into a cup, I teach them how to read a meniscus in a measuring cup at home. So I use this in my everyday life, and everyone should as well. So looking at the bottom of the meniscus is important for making sure you get the correct amount of substance. Sensitivity, the proportion of people who have a disease or condition who have a positive test. It indicates how small an amount can be measured and still produce a positive test result. So I always use the pregnancy test to talk about sensitivity. So if the egg gets fertilized, on day 1, that egg is going to be fertilized, which means that the baby is going to start to develop. But if you were to take a urine pregnancy test on day 1 of fertilization, the test would be negative. It doesn't mean that you're not pregnant. It just means that the quantity of HCG hasn't built up in the urine or in the blood enough to spill over into the urine to be detected at an at-home pregnancy test. The at-home urine pregnancy test isn't that sensitive, because if it was super sensitive, it would be able to detect at the moment of conception, which just isn't possible. So sensitivity has to do with like the quantity of a substance before a test system can detect it. Now, some of these analytes in immunology are super small quantities. Like we're talking about picograms, tiny, 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 tiny amounts. So we have to have highly sensitive test systems available in order to be able to detect those tiny amounts. To calculate sensitivity, you calculate it as a percentage. So you would do the true positives divided by the true positives plus the false negatives times 100%. So a true positive is a positive result and it should be positive. A false negative is a negative result, but it should have been positive. Specificity. Specificity has to do with the proportion of people who do not have a disease or condition who have a negative test. It measures the substance that it is designed to measure, not interfering substances. So if I have a test system that is supposed to specifically detect IL-10 in a blood sample, but the methods that I'm using happen to also turn positive if there's TGF-beta, that's a problem. So that has to do with low specificity of the test. A highly specific test would be able to actually just turn positive for the things that I'm testing for. Some of our microbiology tests can also be this way. So if I am testing for a particular analyte or testing for something very specific, if I take it from an agar plate that has certain types of chemicals in it, it may produce a false positive result because those chemicals in the agar happen to also react with the substance in the same way as the analyte that I'm testing for. So the more specific a test system is, the more likely you are to detect what you're actually trying to detect and not also pick up background substances that we are not trying to include. So this is also measured as a percentage. You take the true negatives divided by the true negatives plus the false positives to get your percent. True negatives are a negative result and they should be negative. False positives are a positive result, but they should have been negative. The positive predictive value, the probability that a person with a positive screening test actually has the disease, you would take true positives divided by true positives plus the false positives. The negative predictive value of a test is the probability that a person will have a negative screening test that does not have the disease. True negatives divided by true negatives plus false positives times 100%. So then you can review the summary slides, and then the very next slides will correlate to the next video that I recorded on basic lab math. Again, if it's a review for you, you can just skim through it. Pay close attention to the part at the end where I start talking about serial dilutions. If you want a complete review of basic lab math, then I strongly recommend that you watch the entire video.